Hello everyone, let's talk about how to do graphing for your Mousetrap car. Okay, I've got some data for my Mousetrap car. This is taken from a slow-mo video of the car out in the hallway, rolling from rest, accelerating, going through its journey, then decelerating and stopping. Now the first thing I'm going to do is I'm going to list in my table of values my time and my position. Now I put time first because I want time to be on the x-axis when we do our graphs. So I put it first because, as you'll remember from math class, we read our x values in the left-hand side column and our y values in the right-hand side. So that's what Excel assumes we're doing as well. Position in meters is going to be in the right-hand column. And of course, I put my units at the top. If you type your units into the column, like say I did 3.5 m, you'll notice it's off to the left-hand side. It doesn't know that this is meant to be a number. It assumes I'm trying to write some text into the box, so that won't work. So just be cautious that it should be on the right-hand, a default to the right-hand side. So I'm actually going to type this first, my positions in. I start at 0, and I know at time 0, my position is 0. And then I want my car to sit there for about 2 seconds. So I'm going to watch my video, and I'm going to find just the instant before my car starts to move, I'm still at position 0. Now in my video, it was at 2.50 seconds. That's just the instant. At 2.51, the car started to move. So at 2.50, I was still at position 0. Okay, I'm going to play my video. I'm going to pause the video at half a meter, 0.5 meters, and I'll check my timer. It says 3.55 seconds. And I'll do that every half a meter. So at half a meter, 1, 1.5, 2, 2.5, 3. Yours might go all the way to like 11 or 12 or 13 meters. My car was not that great. Only ended up actually going just over 3 meters. Okay, so I put in all my various times here. Now my car actually stopped at 3 meters and 12 centimeters. That might be more precise than you can do. If you're not sure, just do your best to estimate, right? Your car will probably stop in between half meter marks, and you're allowed to do that estimate to 1 digit. So you can, I estimated 12 centimeters, right? 3 meters and 12 centimeters. And I also recorded the time when it stopped at 312. Now, I want to have a bit more in my graph to show that it's stopped. So I got to include a bit more stuff. I'm going to go all the way to 8 seconds, 9 seconds, and 10 seconds. I'm just choosing those numbers because they're nice and convenient. And they're more than the time where my car actually stopped. Now, after my car stops, it doesn't move. So I'm going to put in 312 for several data points after that because the car doesn't move, right? The car stays stationary. 3 meters, 12 centimeters is where it stops, and it stays in that position. Okay. Now, some of you might have a car that rolls backwards, in which case your position will actually get to a lower number. But at the end, it should remain at the same number for at least 2 seconds. So to do that, all you do is you put the time where it stopped, the time in position where it stopped, and then you add a couple more position ones where you add a few more seconds, knowing that the position doesn't change. Okay, so now we got our data table. Again, we started with 0, 0. And then we started at the time when the couple of seconds when the car actually started moving. And then we list where it ends. And then we list a couple more times in order to show that it's not moving at the end as well. Okay, so we're ready to go. Let's clean this up a little bit though, shall we? First of all, let's give this a title. Let's say Mr. Roy's Mousetrap car with an exclamation point. Now let's first of all put a box around my data. I kind of do have a data table here, but it's going to look nicer if I grab everything and then I go up to home and I find this little thing with this these grid lines. So I would like to go all borders. Okay, and what that's going to do is now I have these nice grid lines that separate things a little better. I would also like to bold. So again, I'll go into home and I'll bold that stuff. And I also wouldn't mind adding a little bit of color. So this is my position time. For my position time, let's add a little bit of color. I'll get my paint bucket. And I think for position time, I will do blue. That looks really nice. Okay, now I have a prettier one. If I want to make my columns wider, I can go to the top, grab the edge of the column and drag it back and forth. So I'll drag it just a little bit so everything fits properly. Okay, now I can make a graph out of this. I'm not going to grab my titles. I'm just going to grab my data. I'm making sure that time is on the left, position is on the right. We'll go insert to make a graph, and then we'll choose from our options here. I'd like you to choose a scatter plot, but I'd like you to choose the one where it's just smooth lines. This will make it a little easier to see what's going on. So I'll choose that one, and here's my graph. This makes a lot of sense. At the very beginning, I have a flat line. That means my car has zero velocity. It's not moving. Right at the end, I also have a flat line. Zero velocity, not moving. In the middle, I have a pretty straight line, but it's at a slope. And if I calculated the slope of that line, I would know this kind of steady velocity in the middle. And then I have where the line curves, kind of towards the beginning of the journey and towards the end. Those curves, the changing slope means changing velocity. Changing slope, changing velocity. Steady slope, steady velocity. So those changing slope, I see it's getting steeper. So that means at the beginning, it's accelerating. So it's going to be stationary, and then it will accelerate, and then it's got pretty steady velocity, and then the slope starts to get less steep. So that means it's decelerating, it's slowing down. Okay, nice. Let's add a couple things in here. We can add a chart title. So I can say position versus time of Mousetrap car. Okay, I also see there's no axes on the sides. I can click the plus button and I can add in axes titles. So this is my y-axis. Say that's my dependent variable. That's going to be my position. My position is in meters. I also have to list the direction, so I'm going to use square brackets for that. And I'm just going to say forward for my direction. Oh, looks like I had a capital letter. Okay, so my position in meters forward. For this axis title, this is going to be my time. My time is in seconds. I'll put that in round brackets. Now I don't need to put directions because time is a scalar. It doesn't have a direction. Now, if I want to change the size of the numbers or where they go to, I can double click on them, and I'm going to have some options here that I can pick some different options for my axis. I can say what the minimum is, what the maximum is, where the grid lines are. I encourage you to mess around with that stuff a little bit, okay, and see what you end up with. Okay. Let me just make sure I'm still recording here. Yep, looks good. Okay. So we'll say, all right, that graph looks nice. That graph is pretty much ready to go. I might need to clean up things, bold things, change the size, whatever. Let's get that graph out of the way. Now we want to make our two other graphs. We're going to make our velocity graph, and we're going to make our acceleration graph. Okay. For velocity graph, here's what I'm going to do. I'm just going to actually copy this whole thing. Boom, like that. Nice and easy. But instead of position, I'm going to have velocity. And my velocity is in meters per second. Okay, great. And now I say, okay, my time I can keep the same. My velocity I'm going to have to get rid of. Now, if you find you're getting a whole bunch of decimal places and you want to tell it to just only show you 2 decimal places, grab all of those blocks and then right click on them. And then go format cells, and I can go number and choose 2 decimal places. That way, no matter what I type in, it's going to show it to 2 decimal places. And I kind of like that. It makes it nice and neat and orderly. I've also done the same thing for my time values. Now here's how I'm going to do velocity. The first one I'm going to just put in is 0 because I know it's starting at 0. The next one, I'm going to actually do a calculation, and I'm going to have Excel do this for me. If I want to say that I'm entering a calculation, I need to start by hitting the equals sign. The equal sign tells Excel that I'm going to be doing a calculation. Okay, now what I have to do is I want to say, I know velocity is my change in displacement divided by the amount of time it takes. That's literally what velocity means. And we have a formula for that. We say velocity is change in displacement divided by time. So I'm going to do that. Or sorry, I should say change in position, which is displacement. Velocity is displacement over time. So I'm going to find my change in position. How I'm going to do that is I'm going to first put a bracket. what I'm going to do is I'm going to subtract two values to see how my position changes. Okay, I'm going to start with this position right here in C5. I'll grab that one there. I'll just click on it, and it knows that that's the the cell I want to use. So that's my final one. Now I'm going to subtract where I started, which is the one before it, C4. Now I'll put some brackets around it. Now that is 0 minus 0. I know that's going to give me a value of 0, but that's okay because my velocity is 0 at that point. Now I've got to divide that, so I'll put a slash like this. That's the divide symbol that we use in Excel. Now I'm going to divide it by the change in time. My change in time is this. I end up at 2.5 seconds. Oh, I got to put a bracket in there first. 2.5 seconds minus 0 seconds. What's my change in time? My final minus my initial for that stretch. Okay, so I've essentially used the first 4 cells, the first 2 in each column on my position time graph. I'm going to hit enter, and it gives me 0. No surprise there. The velocity is still 0 at that point. Now here's the trick. Rather than having to retype that equation for every cell, my gosh, what a pain that would be. Instead of having to retype it for every cell, I'm going to click on this first one where I put in the formula. You can see it up here at the top. Okay? And what I'm going to do in that cell is I'm going to click this tiny little green box in the bottom right-hand corner. And I'm going to drag that down the whole way. This is going to copy that formula into every cell, but it's going to know that it should go down 1 position each time. Boom, done. There's my velocity. Just that easy. Okay, you'll notice I never have a negative velocity because I'm never going backwards. So that makes sense. I do have a pretty steady velocity in the middle. And at the beginning and end, my velocity is 0 when I'm stationary. That makes sense. My position isn't changing. Okay, now if we want to make a graph of this, we can just grab this data. Let's go insert. Let's go into our graphs, and let's do the same thing. Boom, there's my velocity graph. Now I'm going to have to put in a title and chart axes and all of that stuff. You also notice that it does seem to dip into the negatives here very briefly. That's just because these curved lines are trying to smooth out the motion, which is good because we do want it to smooth it out because realistically that more represents what's really happening. So these changes in motion happen kind of like continuously and smoothly. They're not like herky-jerky. But this shows me my velocity. It's 0 at the beginning, it's 0 at the end, and I have the highest velocity at about 4 seconds. And then it kind of like tapers off from there. Okay, I'm going to tuck that one away. Let's do the same thing, but acceleration. Let's do this kind of fast. I'm going to grab my data. I'm going to paste, instead of velocity, now I'm going to write acceleration. I'm going to put that in meters per second squared. So to do the squared one, I'm just going to do that little upwards caret and put a 2. That's how we would write squared. It's not going to square the number. That's just the units associated with it. Okay. Oh, it looks like I'm missing a C there. There we go. Acceleration. Awesome. Okay, now for acceleration, we're going to do the same kind of thing. We're going to start with 0. We know acceleration is change in velocity divided by the time, the change in time. So let's do that exact same thing we did before. Let's do the change in velocity over each of those intervals divided by the change in time. This is going to look familiar. We'll hit equals. We'll put a bracket. We'll say my velocity in my first interval ended up here, but started here. We'll subtract the 2 to find the change. And then I can say, let's divide that by the change in time. Open a bracket, choose the time, subtract the time that we started at, and close the bracket. So now I have what was my change in velocity in that interval, what was my change in time. Let's divide them. That'll give me acceleration. Boom, it's 0. No surprise. That's what we expected. Let's do the same thing as we did before. Grab that little box, drag it all the way down. Look at this. Just as we expected, we have no acceleration at the beginning when it's sitting still. Then we have an acceleration where it is starting to move forward. It picks up speed really quickly. We notice this in our velocity graph, where there's a big increase in our velocity. It happens really fast. And then we see a slower decrease in our velocity over more time. That's my negative acceleration. It's not as big and it's spread over a much larger period of time. And then we get to the end and there's no acceleration. So we have positive acceleration when it's speeding up, and then we have negative acceleration when my motion car is slowing down, and then we're back to zero acceleration when it's stationary. Let's do a graph. Let's grab my data. Let's go insert. Let's go to my scatter plot, and let's plot this one. Here we go. We got our big positive acceleration. That's that big spike. And then we have this slower negative acceleration with kind of a big acceleration, big negative acceleration right around 8 seconds. Something must have happened there. That's kind of like near the end. So that's just after it stops. So I think this has shifted a little bit, but because we're like taking 2 of them off each one. But anyway, it's like we can see what I'm looking for is the shape here, right? Big positive acceleration, then small negative acceleration with kind of a big drop at the end where that's probably where my string ran out right there, right? Where the mousetrap was spent and there was nothing pulling it, so it really slowed down fast. Or it might be that the axle kind of got caught and slowed down. I won't know unless I look at the video of my car. So that video is going to be really helpful in describing the motion of our car, because the graph can tell us it's changed in position, velocity, and acceleration, but they don't tell us why. We need to look at the video to really figure out the why. So those are my 3 graphs. I'll have to label this one and put axes titles on it and all that stuff as well. But I got what I expected, some positive and some negative. Positive for speeding up, negative for slowing down. Okay, and that's it. That's how we make our graphs. We've got our 3 graphs. Now we can just take these and very easily paste them into our document. I could start a brand new Word document. I could open it up and I can just paste this graph, boom, right into it. And I have this beautiful graph showing everything I need. The two talk to each other really well because they're both Microsoft products. Okay, I hope that's helped, folks. If you get stuck with your graphing, if you have any problems, please let me know and I'll be happy to help. Good luck motion graphing and good luck with your reports. Bye for now.